All right, lovely. Well, then I think we're live and we can get started. So, hi everyone, I'm Liz Eggleston and I run Course Report, which is a resource for choosing the right boot camp for you. This is my one shameless plug that I do at the beginning of every video, but if you haven't looked at Course Report yet, you can use it to research the best coding boot camps, best data science boot camps all over the world. And as you're researching those data science boot camps, I'm willing to bet that you will ask yourself, am I ready to apply for a data science bootcamp? Do I know enough math or statistics or probability to go to a data science bootcamp? Because when we talk about coding boot camps, we're pretty clear that you don't have to be a math whiz in order to become a programmer, but you actually do need to know some math in order to become a data scientist. So in this webinar, we are going to talk about why you need some math skills to be a data scientist, and we'll actually dig into exactly what type of math you need to know. And this may surprise you, but I am actually not a math expert. However, our guest today is, so Kim Fessel is a senior data scientist and an instructor at Metis, which is a data science bootcamp in New York, Chicago, San Francisco, and now, actually very recently, online. So Kim, I cannot wait to pick your brain. Thanks so much for being here.
Absolutely. Thanks so much for having me, Liz.
Of course. Okay, so we're going to show some slides as we go so that you can follow along, because Kim is actually going to be showing us some examples of the types of math that you'll need to know and how to solve a few sample problems as well. So I will post these slides along with this video and a transcript of this video on our blog on coursereport.com after we finish. So Kim, let me share these slides. All right, so Kim, maybe you can just tell us first about your background and what you actually do at Metis.
Sure, yeah. So like you mentioned, I'm a senior data scientist and instructor at Metis, specifically at the New York City Boot Camp. So my background is primarily in applied mathematics. So I'm always happy to talk about math concepts, all of that good stuff. I earned my PhD in applied mathematics from Rensselaer Polytechnic Institute. And following that, I did a postdoc at The Ohio State University in math biology.
Oh,
but
interesting.
But I also have some industry experience in advertising and web content.
Well, yeah, I mean, you have a pretty rich career in data science previous to being at Metis and being an instructor. Just looking at your LinkedIn, you can tell. So what kind of brought you into education and specifically to Metis? Like what inspires you to kind of teach the next generation of data scientists?
Yeah. So right before coming to Metis, I was doing natural language processing at an ad agency, and that was really fun. It was really exciting work, but I guess there was always just a little bit missing. For example, like I really enjoyed teaching back when I was an academic. And my company, this advertising agency, had an internal training program. And as soon as they started it, I was like the head of the line. I want to be an instructor. I just love teaching people about technical concepts, especially, things like coding and math. So it always was really something I really love to do. And Metis really gives me the opportunity to not only think about data science, but also be in the classroom and really, watch others progress in their journey, which is really rewarding.
That's cool. You sound like the perfect data science bootcamp instructor. It came directly from industry, but has a passion for teaching. That's really cool. That's amazing. Okay, so let's dive in and completely back up. So before we even talk about math, for complete beginners who are totally new to data science, can you just tell us what data science is? What are we talking about here?
Sure, yeah. So for total beginners, I usually start out by saying, well, data science is really like blending your math skills with your coding skills and then some business intelligence. And really, if you kind of break down the word data and science, that'll really give you a pretty good clue about what it is. The data part, we're really just trying to make sense of data. Humans are producing way more data than other humans could ever have a chance to look at. So really the core concept there is just let's develop algorithms that will help us learn about our world, learn about our cyber world in a much more structured sort of way. And one interesting thing about data science, when I say data, I don't just mean numbers. Data could really be, a lot of sort of unstructured things. So like text or images or audio files, all of those are what we're talking about when we say data. And so just looking for patterns in this massive amount of information that we have.
Interesting.
And
So
then
that's where that like NLP, natural language processing, would come in.
Yeah, so I'm a little biased. I love NLP, but yes, of course, that would be a component of that text analysis. Yeah.
Cool.
And so that's the data part. The science part is really just kind of talking about how we make all of the magic happen. How are we going to do this and make sense of the data? And so, we found out pretty quickly that you can't just throw data into black box algorithms. You're not going to necessarily know what's going on. So we really need to take a very scientific and rigorous approach to designing the entire setup, asking the right questions, challenging our hypotheses, and all of that, in my opinion, really falls under the scientific approach. So data and science.
Amazing. It's a perfect explanation. And so then when we talk about math, I mean, I think it's interesting because when we talk about coding boot camps, we always say you don't have to be a math whiz to become a programmer. That's like a common kind of misconception. But in data science, that's really not the case. So could you tell us just why that is, what role math actually plays in data science, why you would need math to be a data scientist?
Yeah. So definitely the idea of we're going to blend coding skills with math skills. That's kind of the core of data science. And there's a really good reason why that's the case. The algorithms that we use in data science are all rooted in mathematics. So whether it's an optimization problem or some kind of probability problem, or maybe even just some scoring metrics, all of those things are going to require a lot of math skills to really understand what's going on. And I like to use this analogy of kind of like, in order to drive your car, you don't necessarily need to know how it all works. But if you're going to be a professional mechanic, you really have to know all those component pieces. And for data science, that's going to be the math.
Okay, that is a perfect explanation. Thank you. Okay, so does that mean our next slide is kind of about, about who can, be a data scientist? Like, does that mean that I need to have a math PhD? Who is kind of the ideal data scientist?
So I definitely wouldn't think you'd have to have a math PhD, though it's fine if you do, but you wouldn't have to. A lot of people who actually are in data science right now, I would say either come from the math world or the coding world, or maybe even some kind of adjacent science. But either way, you're probably going to have to skill up in one area or the other, or maybe even both, right? So eventually, you have to be able to have those technical chops in both math and coding, for sure.
Okay.
But, besides those technical abilities, which are really important, I think a data scientist really has to be very creative, which is kind of an unusual thing to think about. But when we really think about what kind of problems we're trying to solve, they are, actual problems. We're not just playing around with data for the fun of it. They're actually problems that our users facing or our customers are facing. So because there's this overarching goal, sometimes we have to be really creative with how we're going to solve the problem. So maybe even that's like, data sourcing or feature engineering, or maybe how we're going to combine those results. Any of those kind of things would require a high level of creativity. Communication skills also, oh my gosh, I can't stress this one enough. Being a data scientist, you really take on this role of both, I have to execute my work well, but I also have to be a champion for my work, right? I have to be able to explain that to my stakeholders and tell them all of the good things I found and tell them what recommendations I'm going to make based off of the things I found in the data. So you have to be able to communicate both verbally and in written communication as well. And the last one I think any good data scientist will have, we talk about this one a lot at Metis, grit. I think grit's actually an important quality in any scientist. Doing these sort of problems, you're definitely going to have some kind of issues as you progress down your project, right? So do you have the determination to creatively solve whatever problem you're working on? Can you stick with it? That's basically what grit is.
And we're going to talk a little bit later about, if someone's watching this and is a complete beginner and is, has 6 months or a year to really focus on one thing or try to learn a new skill to become a data scientist, how to get there. But in your experience, have you taught students who didn't have like that formal training in programming or math and still went through Metis and were successful?
Absolutely. Yeah,
Yeah.
absolutely. And certainly I've had students that have one or the other and really need to focus on one or the other. But I have had students who really didn't come from any of those fields, and that's
Mhm.
totally fine. It's just a matter of you might have to put in a little bit extra work if you haven't studied these sort of topics formally.
Okay. So then speaking of that kind of extra work and what those topics are, let's go through the kind of, meat and potatoes of this webinar, which is the actual math that you'll need to know for data science. So can you take us through what we need to know high level, and then we're actually going to dive into each of these math topics.
Definitely. Yeah. Yeah. So I think like the math you need to know might depend a little bit and what area of data science you specialize in, but I would definitely think these four core concepts are going to be important pretty much for any data scientist. The first one being linear algebra, I would almost say that's the most important one. So many of our algorithms are based in this sort of linear algebra context that it's just really a must have. You got to be comfortable with matrices and vectors, all those sort of things. Calculus, some of the algorithms we use are solved with optimization routines, and that's going to involve taking derivatives and understanding rates of change and things like that. And then probability and statistics, I would definitely say that this is also important. There are, again, some algorithms that are strictly probabilistic in nature, so having a good, strong grasp of what these things mean is important for any data scientist.
And what level generally of each of these should someone know? Like, does this mean you need to have taken a class in high school and really loved it? Or, do you need like a college level course in each of these? Or do you have to have used them, professionally on a job?
Well, that certainly wouldn't hurt, but no, I mean, I don't think you would have to have any sort of level. It depends on, let's say, how advanced your high school was. I know that there are some high schools where people learn calculus, they learn a lot of probability and stats already. That's probably fine. On the other hand, I would say that, if you have that collegiate level of understanding for these topics, you're just going to be that much better off. You wouldn't necessarily have to have had a PhD or majored in math, but just having exposure to these sort of things will really help you kind of loosen up those gears really quickly.
Cool. Okay, that's perfect. Okay, so we'll start with linear algebra. So first, tell us what it is and what kind of concepts you should actually know when we talk about linear algebra for data science.
Yeah. Linear algebra is another one of those where it kind of says what it is in the name. Algebra being just that we have some unknown quantities and we're trying to solve for them. And the linear part refers to how the equations look like how they look. Basically, just any of those unknowns can be multiplied by constants or added together, and that's really it. They can't be raised to some higher power. They can't have like transforms like a log or a sine, none of that. It has to just be, plain old variables multiplied by a constant. That's it. And then the idea around going further with linear algebra is that you'll typically have a system of equations. So lots and lots of different equations describing the same system. And then we're trying to find unknowns that really satisfy that entire system if we can. So the concepts certainly, we start talking about higher dimensional spaces, so vectors and matrices, and really understanding how those computations work. But I would also recommend that someone who really wants to go further with data science understand not just how to do the numerical computations, but actually how to get a geometric intuition of what's going on behind the scenes in linear algebra. And then eventually taking that to something like eigenvalues and eigenvectors. That's, kind of some advanced stuff. But if you want to do eventually things like dimensionality reduction, you're going to need to understand those kind of things as well.
Okay, cool. Thank you for making that connection. Because when we talk about this type of math, I'm kind of curious, like why you would need what part of data science you'll need linear algebra for, Does that make sense?
Yeah, absolutely.
Like where you'll see it pop up when you're at Metis or beyond.
Yeah.
So thanks for making that connection.
Yeah. Yeah.
Cool. Okay, so should we dive into a question?
Sure. Sure.
Okay. All right. So tell us about this example, and the next slide, we're gonna actually solve it, right?
Yep. Yep.
Cool.
Yeah. So this is kind of one of the maybe an example you would see when you first start taking linear algebra, just trying to understand the fact that you can write systems of equations into like this matrix vector form. And we'll see what that looks like on the next slide. But basically just think about how each of these are different equations, and we're ultimately trying to solve for x and y, which are unknown variables.
Okay. So how would we do that?
Ah. So I wrote the equations again over on the left, and then on the right in blue, we have the solution. So basically what we're looking at is a matrix containing all of those coefficients, and then a vector containing all of our unknowns. And if you were able to, do this multiplication back out, you would get what's over on the left-hand side in gray. So just for one example, if I take the top row of that matrix, 1 and 1, and I multiply that by the vector x and y, I'll end up with x plus y, which is exactly what you see over on the left-hand side. And all of that should be equal to the number 1.
Interesting. Okay, so then why does this system have no solution?
I know, I feel like a bully for giving like a trick question on the first one. There's a good reason why I did that. But so if you take a look at, let's go back to the original equations, like the final equation tells us that x should be equal to 2. But if I take that quantity and go back to the first equation, if x is equal to 2, then y has to be equal to -1. But in the second equation, if x is equal to 2, then y has to be equal to +1. So there's really no way that y can be both positive and -1 at the same time, right? So we have a contradiction there. And it turns out that this kind of system is called overdetermined. And it just means that we have more equations and fewer unknowns, and everything just can't work out in perfect harmony. And the reason why I brought this problem up, the reason why I thought this was interesting for us to take a look at, is because this is exactly what happens in linear regression. So in linear regression, the thing that we're trying to find are parameters to describe our system. So our unknowns are actually the parameters of our model. We have equations for every single data point that we've measured. So it turns out we'll typically have way more data points than we will have unknowns. Our system is overdetermined, which just means we're never going to find perfect parameters to satisfy every single data point.
Interesting. Okay, so thank you for explaining that, because I feel like when we talk about like how to get into Metis or how to get into any data science bootcamp, we always hear linear regression. I feel like that's like maybe not a buzzword, but you have to know it for any data science bootcamp. So thanks for explaining it. I appreciate it. Cool. Okay, so we move on to calculus.
Sure.
Okay. All right, wonderful. Okay, so I think everyone's heard the word calculus, but tell us what it is and like which concepts you should actually know for data science.
Yeah, I took a look at this question. What is calculus? It was almost philosophical.
I know, right?
Like, what even is calculus? I don't know.
Yeah.
But I really gave it some thought, and calculus kind of breaks down into 2 areas. One, calculus is a study of instantaneous rate of change. So basically that's anytime you were taking derivatives and you were trying to understand how is this function changing, that's going to be the first part of calculus. The other part of calculus is more focused on how a quantity accumulates. So that's going to be your integrals, right? So between derivatives and integrals, that really makes up the bulk of calculus. And those two happen to be very intimately linked through that fundamental theorem of calculus. So that kind of sums up what calculus is, and also kind of sums up what you need to know from calculus. Certainly derivatives, integrals, but I would also say that a good, data science bootcamp student will know how derivatives relate to other things like gradients or finding maxima and minima. Those derivatives can really be very powerful when you're thinking about other concepts as well.
What kind of concepts in data science would you see calculus show up in?
So definitely that stochastic gradient descent is one buzzword they should definitely know about, right? That's always one of my favorite lectures to teach because I get to use calculus and show off, all the derivatives and those things. So stochastic gradient descent is basically a numerical way to come up with a minimum for a function. So we end up using, optimization functions and minimizing things pretty often in data science. So typically the way that we're going to do that is with stochastic gradient descent.
Okay, cool. All right, so let's hop into this example.
Yeah,
looks like a function.
Yeah, definitely a function. And this one, I wanted to just illustrate that gradient because a lot of people remember how to take derivatives, how to do integrals, but gradient might be one that needs a little refreshing. So in this problem, we're going to try to take the gradient of this function. And you'll notice that this function is a function of two variables, both x and y. So it just has two unknowns. Once we find the gradient, we actually want to sub in the point to -1. So we just want to know what the gradient is at that point.
Interesting. Okay, cool. I'm going to go to the... All right. Okay, Kim, you're explaining
I love
this
this
to a
stuff.
total yeah, that's incredible. Okay, so tell us how to solve.
All right, so I put the function in the upper right just so we have it in our memory. The thing about this problem, the hardest part is just remembering what a gradient is, right? So a gradient is defined. So by the way, that upside down triangle guy means gradient.
Yeah, what is that?
That's a nabla. Yeah, that means gradient. So, taking the gradient of a function just means that we are going to take the partial derivative of that function with respect to each one of its variables. And then after that's done, we'll put all of those into a vector. So it's kind of nice we're linking back the linear algebra with the calculus here. So to do that, now that I know I need the partial derivative of that function with respect to x, that's the first thing I'm going to do. I'll go back up to the function, and what that means, taking the partial derivative, just means that I'm going to treat every other variable just like a constant. All I care about is how does this function change with respect to x only. So if I go back up to that function, if I take the derivative with respect to x, the first term is going to give me 2x. The second term, which is negative xy, because y is treated like a constant, the derivative of that with respect to x is just minus y. And then our final two terms don't have anything to do with x, so we get zeros for those. So once I've computed that partial derivative with respect to x, I can put it into my vector. And then I'm just going to do the same thing, but with respect to y, the other variable, and put it in the second spot in my vector. Once all of that's done,
yeah, go ahead, keep going.
This problem never ends. No, once all of that's done, once we've got the partial derivatives, we put them in the vector. All we have left to do is just plug in the point to -1. So all that means is I'm going to, in that gradient, everywhere I see an x, I put a 2. Everywhere I see a y, I put a -1. And then I just work out all of the multiplication and addition. And eventually I end up with 5, -1.
Easy as that.
Easy as that.
So if somebody is like brushing up on their calculus before they're going to apply to Metis and they can do this problem, no problem, then they're on the right track.
They're definitely on the right track. Yep.
Okay. All right, cool. Okay. So that's calculus. And then let's move on to probability and statistics. I kind of consider these to be in like the same category, or at least learned probability and statistics at the same time in high school, but they are different concepts. So let's start with probability.
Yeah, I would say definitely me too. Probability and statistics are really, really linked, and they're pretty different from linear algebra and calculus that we just talked about, pretty different concepts. But yes, those two are definitely linked together. Probability is just kind of the study of how likely is some outcome, basically. And so the probability concepts, the first thing that, maybe, you would want to spend some time brushing up on is what is a random variable? And it's not, it can get pretty tricky if you go down too far in the weeds with the math, but ultimately all you really need to understand is that a random variable is a variable where maybe we know some properties of the variable, but we don't know its exact quantity yet because that variable depends on some random phenomenon. So we might know something like its mean or its variance, those kind of statistical summaries, but we're still like, recognizing that there's some kind of randomness going on.
It's interesting that you say that, linear algebra is actually the most important math, like type of math that you need to know for data science. Because when I think of data science, I probably think of probability as being most in line with data science, but those like foundations of linear algebra and calculus are probably important to even understanding the probability and statistics stuff. So
it probably depends on which data scientist you ask, actually. So let's keep that in mind.
That's totally fair.
There are definitely some data scientists that really take a statistical approach to data science. And so thinking about data science in that way is kind of just a different frame of mind. I just happen to kind of take more of the linear algebra approach. Yeah.
Love it. Okay, cool. So let's look at an example of a probability question. I kind of love these like word problems that turn into very much math problems. Okay, so take us through this one.
Absolutely. Yeah. So with these probability problems, you're definitely just going to want to practice this kind of problem, these types of problems over and over. So here's an example. What's the probability of selecting a red card or a 10 from a standard 52 card deck? So you're just going to pull out one card. What's your probability that you get either a red or a 10? And the solution to this one really, there's just one trick that you really have to think about for this problem, but you can start kind of dissecting the problem into a couple different stages. The first thing you could think about is just what's the probability that I get a red card? Hopefully you know about a deck of cards and that half of those cards are going to be red. So 26 out of 52 times, you're going to end up with a red card in the deck. And then you could also think about what's my probability of getting a 10. So that's going to be, there's 4 cards in there. That's a 10. So that's 4 out of 52. That's your probability of 10. The tricky thing about this problem is just making sure these two events are not independent of each other, because there are 2 cards in the deck that are both red and a 10, right? We have the 10 of hearts and the 10 of diamonds. Right? So if we're counting those 2 cards in both buckets, the red bucket and the 10 bucket, we've actually overcounted those 2 cards. We counted them twice. So when we come down to like actually computing out the probability, we'll add the probability of red to the probability of 10, but we'll subtract off the probability that you're both, just so that we don't double count those 2 cards. And once we work out all of the math there, we end up with 7/13, which is pretty close to a half. This is a good thing to do with these probability problems as well. Just do a gut check. It's pretty close to a half, which is what we would expect for red cards only. So that kind of makes sense here.
Reading comprehension seems to be
Yep.
an actual factor in probability questions. That's wonderful. Okay, cool. So then finally we're at statistics. And what kind of statistics concepts should I know before I apply to a data science boot camp? I guess we can start with what statistics actually is, sorry.
Sure. Yeah, sure. No, I mean, statistics basically, I kind of think about it as like what we did with data before there was big data, before there was data science, right? It's all about understanding data in a really rigorous way. But statistics, those kind of concepts were really developed before we had all this machine learning algorithms and things. So we were talking about a smaller amounts of data at that time. So things like just even like the mean and variance and those kind of statistical summaries, still important here. But also thinking about kind of what distribution does my data come from? So the probability mass or the probability density functions, and also related, the cumulative distribution functions. Once I know a little bit of something about the distribution of my data, then I can use that to inform a hypothesis test, or maybe understanding p-values or A/B testing. And finally, like the one really cool thing that statistics will give us is kind of understanding and quantifying uncertainty. How do I know how confident I can be in my results? Statistics has a really nice framework for that.
So if somebody knows statistics, then would we consider them like in the modern workplace to be probably in data analytics?
Well, that's a good question. I'm not sure. I definitely know machine learning experts that kind of take a more statistical approach. So
Mm.
I'm not exactly sure how they classify themselves, but
I might be
um,
oversimplifying that.
yeah, I
Yeah.
don't know. Yeah. But definitely
Cool.
statistician is still totally a job functionality for sure.
For sure. Okay. All right. Wonderful. Okay. So our last example is in statistics. Tell us what this sample problem is asking.
Yeah, so this one's probably the most difficult problem. I apologize, but it's the last one. So this one, we are trying to, we've given you here a probability density function, and we're going to try to map out what the cumulative distribution function looks like. The probability density function here looks a little funny. It's piecewise defined. So I'm definitely going to recommend that the first thing we should do when trying to think about the cumulative distribution function is just to plot out what does this PDF or probability density function look like. Cool. So that's what I've done on the top. So there's our PDF over on the left-hand side. And on the right-hand side, there is a plot of what that PDF looks like. If you're not super familiar with these things, I'll kind of walk you through it a little bit. Basically, this function is only defined between -1 and 1. And what that means is just that whatever random variable we're trying to measure is just not defined outside of those bounds. It can never be less than -1. It can never be greater than +1. So maybe there's some kind of rating system or something where we just have absolute bounds for that quantity. So you'll see that the PDF is only defined right there between -1 and 1. And another thing I wanted to point out with this is that any kind of PDF, any valid PDF, should integrate to 1, just meaning that the area under that curve should be exactly equal to 1. And here it is. If you calculate the area of one triangle and the other, add those guys up, you'll be back to 1. And that's really just the nature of probability, the idea that if you add over all probabilities, you'll have a probability of 1. As far as the CDF, again, this is a little tricky, so I would definitely say this is a little bit more advanced problem. But I just wanted to kind of illustrate how the PDF and CDF are linked together. The CDF is basically an integral of the PDF. Basically, what you're going to do is travel from -infinity to +infinity. And as you're doing that, just add up all the probability that you've seen so far. So we're just integrating the PDF, in a kind of rolling basis, right? So one thing to point out here, if I'm adding up all the probability I've seen so far, even at -1, I should still be at 0, right? I haven't seen any probability so far. There's no possible chance that my random variable can be less than -1. So my CDF is going to be 0 up until -1. The other point that you can kind of place in your head is that, again, once I get to 1, I should absolutely be at a value of 1 because I've seen all the possible probability for this random variable. It can't be any bigger than 1. So I should definitely be at 1 in my CDF when I get to 1, and I should level out and stay there. The other bit in the middle is a little bit more tricky. You might notice that half of your probability lies on the left side of 0 and half on the right. So you should maybe know that like at x equals 0, your CDF will be 1/2. But then otherwise, really just if you thought about it for a while, maybe you come up with the fact that if you integrate a straight line, you should get a parabola, which is exactly what we see on both the left and right-hand side.
All right, Kim. Well, I tried to brush up on my algebra and statistics before this webinar, and I feel like these were awesome examples, and you totally explained the answers really well. But I would personally need to study a ton more before I applied to Metis. But I think these are awesome examples, especially for somebody who's like wondering if they are ready to apply for a data science bootcamp. If you can get through these and you understand these examples, then you're probably on the right track.
Definitely.
And kind of speaking of that, we have talked a lot about the math that you need to know for data science. If I'm a complete beginner, say I'm a complete beginner. And I have a few months or a year to, study or get up to speed on all the math that I would need to know for the data science interview at Metis. What would you recommend? Like, tell us about some learning resources that are especially good for total beginners.
Yeah, definitely. So I think if I had a limited amount of time in order to study to, let's say, pass our technical assessment or something like that, the first thing I would do is try to do a self-assessment. I would think about these math concepts and I would try to, recognize which ones were really difficult for me and which ones did I kind of know what was going on, right? So kind of just getting a level of where your comfort zones are, because anywhere that you aren't feeling super comfortable, you can spend more time in those areas. And I would say that's true not just for math, but also coding. If you're a stronger programmer, then maybe you spend a little more time in math and vice versa. Also kind of thinking about how you personally learn best. Some people love to just crack open a textbook and read, and that's totally fine. But other people definitely don't fall into that bucket either. So just kind of trying to understand, do you like practice problems or hands-on examples, or what's your level of comfort? Where do you learn best? And then I wrote down a couple of resources for you. If you are specifically looking for more math resources, I would say that the videos by 3 Blue, 1 Brown on YouTube are really good. And they have lots of different math topics. I think their approach to kind of explaining the different concepts was really good. If you
Cool.
want a deeper dive into linear algebra, I would definitely recommend Gilbert Strang. He has a great book on linear algebra and some really cool lectures from his MIT course online as well. And then finally for stats, I would say maybe the StatQuest videos. They're pretty good about talking you through the really specific statistical concepts. And then finally, if the unstructured sort of approach, if you feel like you need more structure, if you feel like you need more rigor about what to learn and when, of course, Metis has a beginner Python and math course. It's really meant to skill people up in both math and coding so that they are ready for our boot camp.
Okay, that's amazing. We'll put links to all of these resources, but I'm curious, when we talk about the Metis beginner math and Python class, like how far does that actually get you? How long does it take? Is it 12 weeks also?
I believe it's typically 6 weeks. We do have a
Okay.
9-week version, I think, as well, but typically I think it's just 6 weeks.
Okay.
And so it's going to be in the evenings, live online, which is nice. It's really going to walk you through all the math that we talked about today. Pretty much all that we talked about will be in that course. So getting that deep dive in linear algebra, brushing up on calculus and probability, and then even running some of your own hypothesis tests for statistics. So that's all included. And also it contains some Python skilling up as well. So if you want to learn more about like loops and functions and those kind of things, that course also covers that.
Cool. Okay. So these are amazing resources to start with. And then the Metis math and Python beginner class can be a great like structured option once you're like really ready to apply for the immersive. And then once you've done all of that, if you're a beginner, once you've done all of that, then you're ready for the data science immersive, and then people can come take the class with you.
Absolutely, yeah. And we'll talk
Cool.
about even more math, it never ends.
Amazing. Wonderful. Cool. Well, Kim, is there anything else that you wanted to add? I feel like we went through a lot, but any other maybe advice for students who are, have just looked at like the Metis data science immersive application and are thinking about applying? Like what's your kind of advice to a future boot camper?
Yeah, I mean, I would definitely just say, congrats. It's a really exciting field. So I think if you are considering data science, one of the things I really love about it is just there's something for everyone. There's a little math, there's a little coding, there's a little visualization, there's all kinds of like creative ways to be a data scientist. So I think that's really fun. If you are feeling at all overwhelmed, just start with one thing. Just say, here's the one thing I'm going to learn. I'll see how far I can go with it, and then maybe I'll try something else. Just little steps every single day. One other thing that I often recommend to my students is as you are working through various different resources. If there's ever questions in your mind, go ahead and write those down. Maybe later, in a week or two, you'll look back and say, oh, I know the answer to that now. Or maybe you'll say, that question, it doesn't really matter. Or you might say, oh, this is really important. I've got to spend the time actually coming up with an answer to this. So I think that can be really helpful, a little bit for self-reflection and also just to guide your journey.
All right. Well, thank you so much, Kim. I've learned a ton about the math that you would need to go to a data science bootcamp and how much. So we really appreciate you sharing your wealth of knowledge about all the data science math with us. And we're going to post a recording and a transcript of this webinar on our blog soon. And we'll also include contact information for Metis in case this has inspired you to apply to a data science bootcamp. So thanks so much to all of you for watching and joining and learning with us. Tweet at us, email us, and let us know what topic you'd like to see covered on the next Course Report webinar. We'll see you later. Bye.